Hello everyone, I Raghvendra Singh. Welcomes you all in this channel. Okay, so here I will be discussing sequence and series. Okay, as we know, this is the second unit of our engineering mathematics. Let me see, is this recording going on or not? Yeah, so it's going on. Let me focus it. Okay, so as we know that what is sequence? Before this, let me tell you that we will be discussing the complete unit of sequence and series, all tests and how this will be convergence or divergence and all about this, which I know I will discuss in this video. Okay, so what is sequence? We can say sequence is an order of most number. Yeah, we can say it is order. It is kind of order. Okay, like A1, for example, A1, A2, A3, and so on, AN. So we can say this is a sequence. Meaning, how is this used in question? Like suppose we have question like this, and this is n upon n plus 1 on limit n tends to infinity. If we will put here infinity, then upon infinity form, this is infinity by infinity form. Okay, so here what can we do is we can take easily n common. Here will be 1 and here also n common, so 1 plus 1 by n, and limit n tends to infinity. And now here if we will put infinity, then infinity upon, sorry, this to this cancel, and here will be 1 upon 1 plus 1 upon infinity. We know if anything infinity is divided, then this value will be 0. So 1 upon 1 is equal to 1. Means before this answer was coming indeterminate, we use some brain and the answer is actually 1. So these some matriculations we need to do on all questions. Okay, so now we will see that series. So what is series? If someone will ask this question, then what comes on brain? That is the sequence. The sum of sequence is called series. Basically, if we will do sum of all these, then it is called series. Okay, so we can write here that the sum of the sequence is called series. And I have already told you that what is sequence? Any kind of order of number, that is called sequence, like A1, A2, A3 and till AN. Okay, so here's also one formula series, that is n plus 1 by 2. This is the formula which we can directly use in question. Okay, so now we will see the convergent or divergent series. What comes in brain when someone said it convergent or not? Simple. Convergent means finite, finite or a definite, definite, or we can also say unique value. It comes in our brain, so we can say it is convergent. Okay. Summation of un should be finite, so we can say it is convergent. Or if someone said what is divergent, then in our brain comes that is if any number will be in undefined, infinite, or not unique, then we can say it's a divergent. Yeah, so it's as simple as that. Okay, so now we will move on to the next topic, that is let me check it is coming in screen or not. Yeah, so it is coming on screen right now. Okay, so we know that positive terms series, we know that all series terms are positive. All series have all terms positive. Okay, and some important conditions are there. Important conditions are just like for the convergence of series, for the convergence of series, limit n tends to infinity un should be equal to 0. Yeah, we know that 0 is a finite number, so we can say it is a convergent. It's too simple. There's one twist. If this value is equal to 0, then this may or may not be convergence. Okay, we know that 0 is a finite number, and I also tell you that in definition that any finite number is a convergence. But here, if it is we have 0, then it may be convergence, maybe, or may not be. May not be. Also remember this one. But one thing definitely, it is definite, but it is definitely that if any series will be convergent, then sequence will be 0. It's definite. Here is not any may or may not be. It's definite. If any series will be convergent, then sequence will be equal to 0. But if any sequence is 0, it is not necessary that that will be convergent or not. Okay, so let me check, it is recording. Yeah, so it is recording. Okay, so in second point we can write that simple, that limit n tends to infinity un is not equal to 0, then sigma of un means summation of un cannot be convergent. Okay, so now we will move on to the next topic, that is geometric series and nature. Okay, so we will discuss about this topic. So what should be in this topic? Geometric series and nature. What is geometric series? We studied it in 11th class geometry, I think. Geometry series, like a common ratio will be r. R is equal to a2 upon a1. We find r and then we decide. But here is some condition. If r will be greater than 1, then this series will be divergent. Okay, and if r will be less than 1, then series will be convergent. So this is the point which you have to remember. Okay, now so series will be convergent if value of r will be less than 1. Sorry. Yeah, so if value of will be -1 or 1 in between, means this value will be equal to 0. And r is greater than or equal to, yeah, if this value will be 1, then it will be divergent, or greater than 1, then it will be divergent. Or here r value should lies between -1 to 1, means basically here comes then -1 to 1 some points and 0. Okay, so basically geometric series will be something like this: summation of r to the power n is equal to 1 to infinity is equal to r plus r square plus r cube plus r to the power 4 plus r to the power n. So yeah, basically how we will find here ratio. Now suppose this is a2, this is a1. So we usually used to do that a2 upon a1. So here r square upon r means r. So here r is equal to r, means ratio will be equal to r. So basically we do this. Suppose now example, we have given one series, that is 1/2 plus 1/2 square plus 1/2 cube plus and 1/2 n. So how we will find ratio? That is this. Suppose this is a2 and this is a1. So a2 upon a1. So we can do that 1 upon 4 upon 1 upon 2. So this 2 will be here. Then 2 upon 4. This is equal to 1/2. We know this is less than 1 or greater than -1. So we can say that this is convergent because r lies in -1 to 1. Okay, and suppose second, 3/2 plus 3/2 square plus 3/2 cube plus dot. Okay, so what will be here? Like we will do the same thing, that r is equal to 9/4. We simply did 3 2s are 3 3s are 9 and 2 2s are 4. Okay, upon 3/2. So this 9 into 2, 4 into 3, 9 into 2, 4 into 3. This is 3 3s are 9 and 2 4s are 2 2s are 4. This is 3/2. Now here we think that it is 1.5, and this value not lies in -1 or to 1. So this is divergent. If this is greater than 1, r is greater than 1. Okay, so I hope you have understood the concept of geometric series. Again, remember, if the value lies between -1 to 1, then it is convergent, and if the value is greater than or equal to 1, then it is divergent. It's quite simple. Okay. One second. Okay, yeah, this is okay. I'm going to go with this. Let me check this page is complete or not. Yeah. Okay, sorry for the disturbance. Okay, now we are going to discuss hyperharmonic series. Hyperharmonic series. Okay, let me check again if it's recording or not. Yeah, so it is recording. Let me on this. Okay, we also call it P series. Okay, so an infinite series summation of 1/n to the power p, 1/n, 1/1 to the power p, plus 1/2 to the power p, plus 1/3 to the power p, plus dot 1/n to the power p. These are infinite series. So here's the concept of p. This is also called as a P series. Okay. Yeah. So first, convergent if P is greater than 1, and second, divergent if P is less than or equal to 1. So this is important to learn, that P is greater than 1, then it is convergent, or P is less than or equal to 1, then it is divergent. Simple to learn. We will directly use in question, and we can simply see what is series, and directly we can say that it is convergent or divergent. Okay, so remember this. Suppose we have one question. For example, here's one question: summation of 1 upon n to the power 3 by 2. So here, if we will compare it from 1 upon n to the power p, then here what we will get, that p is equal to 3 by 2, and we know p is equal to 3 by 2, it is around 1.5, it is greater than 1, so we can say it is convergent. Okay, it's quite simple. And suppose second example is summation of 1 upon n to the power 1 by 2. We will take this one. So what will be here? We will compare it from this one. So here p is equal to 1 by 2. We know that it is less than 1, or so it is divergent. We know if anything will be less than or equal to 1, then it will be divergent. Okay, yeah, so it's simple. Okay everyone, so now we will see comparison test. Okay, let me see, it is completely visible. Yeah, so it is visible. Okay, so what for a positive term series only. Term series. Summation of un or vn. There are any positive term series. Okay, positive term series. And one thing, that if un will be divergent, then vn also. Okay, if L is, so how we can write it, like okay, so firstly we will see that how to apply this method. Okay, so first is un is equal to function of n upon function of g. So when both should be polynomial, both should be polynomial. We know that what is polynomial means n to the power 2, like suppose x square plus 2x plus 2, which can say this is polynomial. Okay, now let's see one question on it. Okay, let's turn on the. Okay, so question on this will be like, check if it is convergent or not. It is recording now. Yeah, it is recording. Okay, so question is 1 upon 1 into 2 into 3 plus 3 upon 2 into 3 into 4 plus 5 upon 3 into 4 into 5 plus. Well, let this is equal to un. here how we will find Vn. The method of finding Vn is the coefficient of that equation. How this is equation, we will find the common factor between these all by the AP series formula. So here's 1, 3, 5. We know that AP series formula, that A plus n minus 1 D. Okay, so this is A and this is A1 and this is A2. So we know that D is equal to A2 minus A1. So A is 1 plus n minus 1. So n minus 1 as this, and D A2 minus A1. A2 is 3, A1 is 1. 3 minus 1, that is 2. Okay, so we will open it, that 1 plus 2n minus 2. So this will be 2n minus 1. Okay, yeah, so now okay, so we have this. We need to also find the common factor of this one. So like take this one, so that is 1, 2, 3. And there is A1, there is A2, A plus n minus 1 D. Okay, so this is 1 plus n minus 1 D is 2 minus 1, that is 1. So ultimately this will be 1 plus n minus n. 1 cancel, it will be n only. Same with this, it is 2, 3, 4. Okay, now I'm doing direct. So this is 2 plus n minus 1 D, 3 minus 2, that is 1. So again here will be 2 plus n minus 1. This is n plus 1. And 3, 4, 5. So here 3, A plus n minus 1 D, 4 minus 3, that is 1. And 3 plus n minus 1, it will be n plus 2. Okay, so n plus 1, n plus 2. So in place of these numbers we will put this 1, 3, 5. In place of this we will put 2n minus 1. Okay, so we will put like 2n minus 1 upon n into n plus 1 into n plus 2. Okay, now what can we do? That is equal to u. We can take common. So if we will take n common, okay, if we will take n common, then n 2 minus 1 upon n. Okay, here n means n cube. Okay, so here will be 1 plus 1 upon n. This n goes in divide. Okay, and 1 plus 2 upon n. Okay, so here n and cancel. Here will be n square only. So now we have 1 upon n square. So this is our Vn. So here we have find it out, that is Vn is equal to 1 upon n square. Okay, so from here onwards we can directly, if we will compare it from 1 upon n to the power p, then p is equal to 2. It is finite, it is greater than 1 because it is convergent at 2. Okay, it is convergent at 2. Now if we will put limit n tends to infinity on this, like 1 upon n square, okay, no, first we will do that un upon vn. Basically we do this in comparison test. Okay, comparison test, we will do this according comparison test. So our vn is to this whole, okay, 1 upon n square 2 minus 1 upon n upon 1 plus 1 by n into 1 plus 2 by n. Okay, upon vn is this 1 upon n square, 1 upon n square. So this to this whole will be cancelled. Okay, 1 upon n square to 1 upon n square. Okay, so now if here we will put limit n tends to infinity, n tends to infinity. Okay, let me do this in by black pen. So 1 upon anything to the power infinity, anything upon to the power upon infinity, this goes to what? 0. Okay, we know this. So this is 0, this is 0, and this is also 0, and this is also 0. So what is remaining here is, that is 2 minus 0 upon 1 plus 0 into 1 plus 0. Okay, ultimately we are getting 2. So we have said again this is greater than 1, and we know that if p is greater than 1 then it is convergent. So yeah, somehow we did this. Okay, now let's move on to the next topic. Basically now let me summarize it. What we did in question is, first of all this is given to us, so somehow we need to just write the general terms. Okay, we call it general terms. So we will write it by AP theorems, a plus n minus 1 d. By this we got this one, from these all we got n plus 1, n plus 2, and we have just put it here and we get the value. We can simply compare from here, but if we will put limit then we will also get the 2 only. Okay, okay, so now this let me drink water. Then after sorry, okay, so now let me check it is focusing or not. Okay, so now we will discuss ratio test. We also say this Delmart I'm not sure with the spelling. Ratio test or only ratio test. Okay, again one thing, that is it is only for positive term series. Okay, if un is positive term series, then limit n tends to infinity. Check it is recording. Yeah, so limit n tends to infinity, un plus 1 upon un is equal to L. Okay, so this is what we used to do in ratio test. Here's some conditions. If L is less than 1, then it is convergent. Okay, if, let me check it is complete recording now. If L is greater than 1, then it is divergent. It's divergent. Okay, if L is equal to 1, then here ratio test fail. Okay, now we have seen some conditions. Now we will see that where to use it. Where to use it in questions. We can also solve that by comparison test, but that was second type of question. Now here we need to apply the ratio test, but where we will use it. So first condition is, if in question factorial, you know what is factorial? That is something like this. If anything, suppose here is a factorial 4 factorial, then we can write it 4 into 3 into 2. This is basically what factorial actually mean. Okay, if factorial is present in question. Okay, yeah, and if x is, second is, if x is present in terms, then we say that, sorry I've just moved on to the flow. So then we say, in the series, then we use ratio test. Okay, yeah, and yeah, if x, yeah, one thing you need to remember that here also write down to these some conditions here. Yeah, we will use comparison test when x is not present in the question. Then we will use comparison test. If x is present in the question, then we will use ratio test. And the third condition is, yeah, same, that if comparison test not applicable. This third point is obvious. We know that if there will be x, then we cannot solve that by comparison test, and there will be any factorial, we cannot solve by the comparison test. And same thing we write in third step, that if comparison test will be not applicable, then we will use ratio test. If comparison test will be applicable, then we can easily solve by comparison test. Why we will use this method? It's quite simple. Okay, now just let's take one question. Suppose question is, test it is convergent or divergent. Okay, let it h un. Okay, so here 1 upon suppose 2 root 1. Basically it doesn't mean here will be only 1 upon 2, I think so, plus x square 3 root 2 plus x to the power 4 root 3 plus dot. Okay, so how we will solve this? Again, here are some terms. We will convert it into general forms. What are that? Like in n or something else. My battery is very low, so let me recap it very quickly. Okay, so I have no such time. So here we will solve it by, again here we can write it as x power 0, anything to the power 0 it will be 1, and here we have only write 1, so here we can write that 0, 2 and 4 by AP series a plus n minus 1 d. Okay, so 0 plus n minus 1, 2 minus 0, that is 2, so this will be 2n minus 2. Okay, and now same with this one also. Here 2 3 4, 2 3 4, so simply 2 plus n minus 1, 3 minus 2 is 1, so this is equal to 2 plus n minus 1, so n plus 1. Okay, yeah, so here n plus 1, so here it is obvious that here's 1, here's 2, here's 3, then it will be just here will be n. So basically now we can write it as x to the power this 2n minus 2 and upon n plus 1 root n. Okay, so this is basically un. Okay, yeah, so we have found the general term. Okay, now we will do what? Un plus 1. Basically we will put in place of n plus 1, so like x of 2 n plus 1 minus 2 upon, literally my battery is very low, I'm just scaring, it should be not switch off, although my whole hard work will be waste. So here n plus 2, sorry, n plus 1 plus 1, again here n plus 1, so we can write it x square, x to the 2 n plus 2 minus 2. Okay, and here n plus 1 plus root n plus 1, so here 2 to 2 cancel. Where I did mistake? Oh, let me remember it. Okay everyone, so here is actually n plus 1, so here will be n plus 2. Okay, n plus 2. Okay, n plus 2 and root of n plus 1. Okay, yeah, n plus 2 root of n plus 1. So here, let me on the torch. Yeah, so now it is visible. Okay, what was here? N plus 1 x to the power 2n upon, what was this? N plus 2 root of n plus 1. Okay, so this is equal to un plus 1. Okay, now we know that. Now we have to do what is ratio test. Ratio test equal to un plus 1 upon un. So what was un plus, what is un plus 1? It is x power 2n upon n plus 2 root of n plus 1. Okay, yeah, upon what is un? So we saw here that this un is equal to, un is this x to the power 2n minus 2 sorry. Okay, so and un is x to the power 2n minus 2 sorry, upon n plus 1 root n plus 1 and root n. Okay, so this was our un. Now we will solve this to this x power 2n into n plus 1 root n, it is separate, upon n plus 2 root of n plus 1 into x to the power 2n minus 2. Okay, so this is here, as we can see, we can write it as x power 2n and minus x to the power into x to the power minus 2. Okay, so this to this can be cancelled. Okay, now here x to the power minus 2 and this n plus 2, here n plus 1. We can also write it as, okay, so what can we do here? This is root n plus 1 and this is n plus 1. So root n plus 1 root n plus 1 is equal to n plus 1, and we can cancel this by this, and we can write root of n plus 1. Okay, finally what we left is root n plus 1 upon n plus 2 into x to the power minus 2. Okay, and also limit is going, limit n tends to infinity. If we will put here infinity, then we will receive that infinity only. So what can we do here is, we need to take n common. So how we will take this? So n 1 plus 1 by n. We can do this. This is all in root. Okay, and here just 1 plus 2 by n to x to the power minus 2. This is 0. This is upon infinity. If anything divided by infinity, that is always 0. This is also 0, means root n plus 0, sorry, root n 1 plus 0, means here will be 1 plus 0, and so here will be also infinity. Here we will take n common. Sorry. Here I am writing this same thing. We are not just root n 1 plus 1 upon n and n 1 plus 2 upon n x to the power minus 2. Okay, so somehow we need to just cancel this. How can we cancel it? If this will become outside, then it will be 1, it will be n. Root n, here we can, n can be written as root n into root n. Root n to root n cancel. Now this is here root n. We need to just also cut it. So here we will put infinity, and this is 0. This is also 0. So here we are like lefting with x square, x to the power minus 2. It will go up, then x square upon we are lefting with this. I don't know, it is getting more complex. Now how we will solve this further? Oh, I did somewhere mistake, I don't know where. Okay, so we will be left with this only. Okay, now we will be discussing Rabi's test. We use this method when comparison test or this test we discussed recently is ratio test, or Delmard also fail. Then we use this method. Okay, so just I'm not discussing so much, just I am writing the formula. So its expression looks like, check this recording. Yeah, expression looks like limit n tends to infinity and un upon un plus 1 minus 1 is equal to L. Okay. So yeah, some topics, some headings we need to remember. Remember, that's all. That is, if L will be greater than 1, then it is convergent. And the summation of un, L will be less than 1, that is divergent, and also summation of un, L is equal to 1, then Rabi's test fail. Okay, so major topics, let me check this recording. Oh, so sorry, it was not recording. So major test we have discussed. Thank you for watching this video.